Okay, good afternoon, everybody. Sorry, I don't have the microphone today still, so please be quiet and be attentive. Okay, but this class is important. Today we will discuss about an important topic of not object-oriented programming, actually programming. The topic is what is this one? The topic is recursion. Okay. So, but before I start my class today, I want to give you some few reminders. First of all, is that your next test will be in your next class, right? In your next class will be your test. Okay, so we will cover mainly object-oriented principles, inheritance, polymorphism, abstract class, interface, and string processing, and GUI. Okay, so still you have to answer 6 questions, and please remember that last time I told you you do not need to write even the main method. Some of you spend your time, you even wrote import statement and the whole printf. Okay, that was redundant. So you killed your time. Unless specifically asked, you do not need to write even a main method, the main method. Whatever is asked, just write. If I ask you to write a class, just write the code of the class. Okay? Then that will save your time. Okay, and another thing that there will be no makeup test anymore. So if you miss your test, then your final will be the makeup. Average of your final will be the makeup, but you will lose something. Definitely, if you appear for the test, you will know what kind of questions, what kind of topic we discuss, and then definitely you will be benefited. Okay, and then if you are late, if you become late on the test day, you will not get extra time. Okay, my time here is class is 50 minutes, and then the test is 45 minutes. Okay, but if I can start a few minutes early, then I can give you a few minutes extra time in order to write your name and then information. Okay. So anyone so far has any question? Yes.
So with the GUI stuff, are we gonna have to like hard code like actual like scene or something? Because like C# you just kind of drag and drop pieces onto like a scene to make a GUI, and then in Java you have to hard code everything. So that's are we gonna have to hard code
for the test you don't for GUI just read the slides. Okay, just know the basic information and go all the way to the maybe the last page of the slide. I discuss some characteristics or features of GUI programming, the steps that are needed. Okay, memorize those steps, remember those steps, and you don't need to write any large set of code. For any listener or any method, you don't need to read. For lab, for theory, but for lab, you need to do that. Okay, I don't encourage to memorize code. Okay, whatever I discuss in our class, that should be sufficient. If you watch the lecture videos, or if you actually attend in the lecture, that will be fine. But if you need to recap, then go to the video and then watch. Another thing is that I recorded one of the video. So mainly we discussed polymorphism, method overloading, and method overriding. On that class, my voice sound was not recorded. Unfortunately, sound was not recorded. So I just make up that course, whatever I could recall, from another section video. So I added this one. You see, this video is 1 hour and 7 minutes long. This was not originally from your class, but I did make up it because the original video did not have sound. Okay, so in order to do well in the test, you must know this. At least you will get one question from this lecture, and another question from this one, from abstraction, another question from inheritance, and you will get question from object relationship, object hierarchy, and string operation. Okay, anyone has any question? Thank you. And so far we are on the halfway of this course, but we discuss the main stuffs, main topics of this course: object-oriented principles and object-oriented concepts. So at this time, at this point, I believe everybody should have a good foundation of object-oriented programming. And in the next topics that we will discuss how to utilize the object-oriented programming concept. Like for instance, you will start that when start working with GUI programming. You will implement all of your object-oriented inheritance, abstraction, polymorphism concept, polymorphic knowledge. Okay. So unless you understand these stuff, this class will not be helpful for you. Okay, so for the test 2 will be important, your measurement, that how much you have learned for this course. Actually, that is actually measured by test 2. The hard part, key part of this course is within these few chapters for test 2. Okay, today we will discuss something really fun. Okay, recursion. Okay, this topic is recursion is really fun and it is pretty small, and then you don't need to remember a lot of things. For this one, you don't need to memorize a lot of things, but you need to understand some tricks and techniques, how to use this concept, recursion concept. So recursion means calling itself. Okay, when a method can call itself, or when a method calls itself, then the method is called a recursive method. Okay, and the process is called recursion. Okay, so that means saying that a recursion method, okay, so a recursive method calls itself. Okay, so the question is that how long it will call itself. That depends on some base cases. So usually the recursion process is that how usually we do walk or run. So we walk, right, on the street until a certain point. So, so from our early childhood, we can walk. So when we walk, ultimately, that every step, when we put every step, another step up, we only put one foot up, then another foot down, another foot automatically back comes up, right? The walking process, while we walk continuously, unless there is no problem, health issue. Then after a certain point, then we either stop, or we either turn right, or we either turn left, right? So walking is kind of recursion. Okay, but we do not walk infinite length. We always walk or run for a certain distance. So we know the limit, that this is the crossroad, or stop sign, or turn right, or turn left. Those are our base. We start from a point, base, and another base is our last point, destination. Okay. Usually when we run, we start from a point and we stop in our destination. Okay, but in recursion way is reverse order, kind of. Okay, we start from the end and we stop, we come to the beginning almost. It's an alternative way. So let us see that with I will show that with some demo programs. Okay, recursion in programming, recursion had a lot of uses. Mainly the for loops or looping statement can be executed through recursion. As we know that we can execute some statements for a certain time, that is called looping through for loop or while loop, right? So that can be done using recursion as well as. Okay, so in recursion, one of the important aspects is in recursion statement is that, okay, in recursion it uses stack operation. So in your data structure class, you will learn about stack more, but in our maybe next week, we will discuss about stack in depth in stack operation, something, some startup of stack operation. Yeah, maybe after linked list, 2 weeks from now. But for now, remember that stack is a file. Okay, is a memory. Is a memory location where you put some stuff temporarily, not permanently. Stack is a temporary memory location, and I will show you how to do a recursive process and why and how stack operation are used. Okay. So there are two things you mainly need to remember. First of all, to determine the base case, that is, what is the stopping point of your recursion. Okay, that I was trying to give you a simulated example of recursion as walking. When you walk, we stop at our destination, right? But here in recursion, I told you that it is a recursion is kind of reverse order of walking. So we stop here, is a stopping point. So first we need a stopping point is your base. But while working, we consider that our starting point is a base. But here in recursion, we consider as that your stopping point is your base. Okay. And then second thing that you need to do, what is the case that just one step above it, or one step for before or above or before the last stop. Okay, so maybe this is still maybe not clear for you, but I will go through this with a program. I will discuss that what is this means one step before, above or before. Okay. For instance, we are here, everybody will learn how to determine factorial of a number. We know that factorial of a number, for instance, factorial of 5 equal to 5 into factorial of 4, right? So we know that factorial 5 equal to, we know that 5 into factorial 4 equal to 5 into factorial 4, right? Equal to 5 into 4 into factorial 3. So that means we use this formula, factorial of n into factorial of n minus 1. So there is a base case over here, the stopping point. So what is our stopping point? Our stopping point is, as we know that either there is no factorial for negative numbers. So we have to stop either at 0 or at 1, right? So we know that factorial of 1 equal to 0. Sorry, factorial of 1 equal to 1, factorial of 1 equal to 1, or factorial of 0 equal to 1. So either these or that will be my stopping point, my base. Otherwise, we would go in an infinite steps here, but we do not go while determining factorial of a number, right? We stop when we get like equal to, when we equal to get 5 into 4 into 3 into 2 into, we say factorial of, even we say 1 into 0 factorial. Okay, we do not go beyond of this point. So this is my base point. Either this may be my base point or this can be my base point. So here, so similar way, so that we will call this, if we define a factorial method, then with this, our factorial 0 or 1 or 0 will be my base point or terminal point or my ending point, stop point. Okay, so it is very important to understand your stop point or your base. So without a base case, without an effective base case, your factorial or recursive method will not work. What will happen? It will be going infinite. It will become an infinite loop. Okay, so we will show that soon with a program or more detail. So far, anyone has any question? So everybody understand about factorial, right? Anyone is new about this factorial concept? Okay, that's good. Everybody knows this. Okay. So for instance, then using our previous concept of factorial determination, that we will use, for instance, if n equal to 1, for instance, if we define a method factorial as a recursive method, then all recursive method most of the recursive methods or some recursive method takes an argument n, for instance, n or x. These n or x, this argument variable, okay, its value, if it's a 1, then we are calling returning 1. That means this is our base case. Okay, so that means if we give factorial of 1, if we want to find factorial of 1, then we will return 1. That means factorial of 1 equal to 1. Okay. So then what if n equal to 0, n equal to 2? So, okay, what if n equal to 0? Because it will not reach to n equal to 0. Because my base point is n equal to 1, so that is my stop point. Base point is my stop point. It will not go beyond of 1. It will stop at 1. So there is no 0 will occur at this point. So then how about 2? N equal to 2. So as we know that factorial of 2 equal to 2 into factorial of 1. So since in our base method we are putting factorial, if n equal to 1, that means factorial of 1 equal to 1. If n equal to 1, then we are returning 1. That means factorial 1 equal to 1. Then that means at this point it will return in reverse order. Stop here, but it will return 1. So then we will get factorial 2 equal to 2 times 1 equal to 2. So using this recursive fashion, okay, so then all other cases except the base will be very simple. Return n times factorial of n minus 1. Okay. So then my complete method for a recursive factorial will be like very simple as follows. This. Okay. If I say int, that int is my return type. Okay. And this is the return value. You know, in general, a method cannot return a type if it does not have any return type. This is return type. A method cannot return a value or return a statement, cannot have a return statement without this return. Some of you did mistake in your test, and then you argued that I found this information on the first year experience page. In the first year experience page, I reviewed that there are some mistakes. Actually, there was not the only one resource that we should follow. Okay, even if I do some mistake, as a human being, I am not a perfect. If I do a mistake, you don't need to follow me. Some of you said, okay, so in the first year experience page, there is no switch for the case statement, so this is why I do not want to, or did not mention switch. Actually, but switch, without switch, a case statement does not work. Okay, similarly, without a return type, a return statement does not work. So you see that very simple, this method, this recursive method. Okay, so everybody understand this? Okay, so this code, so this code is very simple and it is straightforward. And is there any difference between C# and Java for this one? No, same thing, right? For C# and Java, same thing. But some of you maybe can do this way. Instead of 0, you can say 1. Sorry, instead of 1, even you can say 0. That means factorial, you are using your base as factorial 0 equal to 1. Or even if you use 2, that means factorial 2 equal to, your base will be, then phase will be 2. Okay, so even if you say you want to make your base at 3, then what should be the return value? Factorial 3 equal to 6. Okay, but if you do this way, if you do this way, that you have not reached actually at the stop point at the base, you are skipping something, but you may lose some point. Okay, so but this is why we really need to understand what will be my base case, and then where should I stop. So if even for in case of factorial, we should use 1 or 0 as my base. So everybody clear at this point? Okay. So if you are clear, then you will see on this slide how factorial of 5 is calculated in recursive order. So here, for instance, if we gave 5 as when we call this factorial method, if we put 5, okay, for instance, where if you let me add another method, maybe main. If I add a main method over here, so sometimes I can write this way in order to save my space. I can write this way. For instance, if you have a main method, okay, so again I am telling you, if unless not us, you do not need to use even main method. Public static void main, I say string args. We can put the over here or there. We will call this factorial. For instance, if we want to call this factorial method with a 5 value. Okay, so then if we call this factorial method, recursive method, with a value 5, then what will happen? It will happen like this. Internally, when you call factorial method with 5, then it will call 5 will call factorial 4. Then it will call your internal stack operation like this way: 5 times factorial 4. Then next step will be 5 times. Then this factorial 4 will call itself factorial 3. Okay. Then this factorial 3 will call factorial 2. This factorial 2 will call factorial 1, and since our base is factorial 1, this one will return 1. So then, and then finally it will be multiplied from this way: 1 times 2 times 3 times 4 times 5 equal to 120. Okay. So here that means how it will be actually values will be returned. This one will be returned as 1. So then at this point it will return factorial 2 equal to 2 times 1. That means 2 will return. This will return 2. This one will return 1. This one will return 2. And this one will return actually factorial 3. That will be 3 into factorial of 2. What is factorial 2 returning? 2. So that means 3 into 2, that it will return 6. And then it will return 4 times 6 equal to 24. That means factorial 4 equal to 24. And it will return 5 into factorial 4. We know that factorial 4 will be returning 24. So that means it will be 5 into 24, that 120 will be returned. And finally factorial 5 will be 120. So everybody understand this? Anyone has any issue? If this is a like base, for other methods we will not discuss through in depth like this. You have to remember that when you do recursive call, it goes like this way. It goes all the way end until the base, okay, and then will be returning starting from the base. So everybody is clear? If you understand these one clearly, then it will be very easy to understand or implement other recursive methods. Okay, but if you do not understand this foundational concept, it will be hard for you to implement any recursive method. So anyone at this point, anyone has any lack of understanding? Don't shy, please, but raise your hand if you need help. Good, everybody? Good? Okay, thank you. So this is with our previous understanding. This is so the very simple implementation of factorial. So here actually intentionally I did a little bit change on line 11. You see, this is why I put my cursor on line 11, line number 11, because you can do something. I did something. So instead of, you can say n less or equal to 0, even you can put n equal to 0, or you can change n equal to 1 for the base for factorial. Okay. So now it should be very straightforward, right? And then here at this point there is a static. You know the static keyword. You remember that? Why do we use static keyword? So in order to call a method of a class, all methods are actually in Java and in object-oriented programming, Java and C#, all methods lie within a class. So here my class is recursive factorial name. Okay. Usually, okay, an object is needed to call a method. We know that, right? A class contains some fields and some methods in order to call those methods or something. So, but when you use static keyword, then you do not need to create an object to call the method. This is why you can do like this way, in regular fashion. We are calling here factorial n. But if you do not use static over here, so then this line will show you an error, and ultimately you would need another line to create an object of this class to call this factorial method. So at this point, everybody should know how to create an object and how to call a method by using dot operator with the object, right? Those are the foundation knowledge of object-oriented programming. So this program, okay, I will go through a live program, explain this, but anyone has any question about this one? So intentionally why I put my cursor over here on line number 11, because you see that even if I say n equal 0, it must be a logical operator. If you say n equal 0, you will lose point. Your program will not work. Some professors, like even in our country, when I was a student, they gave totally 0. If you say on one mistake, for instance, if you put instead of logical operator over here, it means double equal, right? If you put one equal, some professors are so hard that they will give 0, total 0. But we are flexible that we deduct few points. But you need to understand that so this is actually, if I want to test your foundational skill of factorization and recursive, then definitely this will be an important aspect to test. So we cannot skip it. Anyone has an issue? So you see that recursion happens here, but internally, visually you do not see that any recursion is going yet. Just you are saying that n equal to n times factorial n minus 1. That's it. So and sometimes people, while doing recursive call, they do a few mistakes. Either they skip the base case or write the recursion steps incorrectly so that it does not converge. Recursive method is conversing, it goes narrow down. It does not narrow down to the base case, and that will cause an infinite loop. For instance, instead of making factorial returning n times factorial n minus 1, if you do n times factorial n plus 1, what would happen? So if you do n times return here n times factorial of n plus 1, it will be going up. Okay, so it will go to the opposite direction to your base. So it will never reach to your base, okay, and it will not reach to your destination. So this is one important thing that you need to remember. So that is called, it says, infinite loop. Okay, so in order to understand more in depth about recursion, we need to understand stack operation. So at this point you do not understand stack. So I'm thinking how can I explain this, but it is maybe we can maybe this slide is very important, but this slide is very abstract. At this point, I don't know how to explain you, because you need to know stack. But by the time you understand recursive operation, and next week, few weeks, when we will discuss stack, please remind me. I will revisit this page one time. If I forget, okay, please remind me. Okay, so this is sometimes there is an important error. This is called stack overflow. Sometimes if your stack is so heavy, is full, it cannot hold your if you do not convert to your recursive base, then stack overflow. This if you do some mistake in your program, then sometimes it will return you stack overflow method. If you say n+1 over here, so then sometime stack is a certain memory location. Stack will be full. Its capacity, when it passes capacity, then it will give you an error. The program will stop. Okay, so once you understand recursive way, then there are some problems that can be solved easily. For instance, finding the value power x to the power y. What will be the base over here, x to the power y? If I want to find x, what will be my y value, base? X to the power y. Anything we know that x to the power something, x to the power 0. Anything something to the power 0 equal to 1. So we can consider as y equal to 0 as our base, or even if we say base equal to 1, then it will return x. If I say my base equal to here, if I say my base y equal to 1, then it will return x to the power 1. That means it will return x, right? And if I say my base equal to 0, then what it will return? If I say 0, then what it will return? 1, right? Everyone understand this? It's a very few lines, okay? If I can say like this way, if base equal to this, then maybe return 1, or I can say this way, or if base equal to 1, then what will return? Anybody tell me, please? X to the power 1 equal to x. Yes. So base cases depends on your problem. So for factorial method, we use base when you say x equal to factorial. Say when you say value 1, then we return 1, right? But here it depends on your problem. So base is not a fixed value, and it depends on the situation or on your problem. So anybody has any issue understanding this up to this? Okay. So this is a power factorial example with this is the method that so this program here I have implemented here with Java. Okay, so if y equal to 1, then return x, and same program I have here with C#. So anyone has understanding this? You see the difference between this in C# and Java is very simple. Not many, because in Java we write in m is in lowercase, and we use system.out.println. and in C# we write m is in uppercase, and instead of system.out.println we use console.writeLine. And this console.key read key is just used to halt the output screen. I usually use, so that until I press any key I can see my output. So anybody has any question about this? So here recursive call is happening here, right? So I am calling power of x comma y minus 1. That is, every time after calling, my power is reducing by 1. And how long it will reduce? Until it goes to 1. So it will not go to negative. At this case it will not go to 0. At this case it will not go to. Even here on this line, if I say if y less or equal to 1, instead of equal 1, equality operator, I could say less or equal 1. So it must be a logical operator over here. Okay. Can anyone please tell me or guess what will be the output from this method? A single line of code, like actually left side is in C# and right side is in Java. Same program. Focus either one side, whatever you understand with Java, or if you understand Java more, then focus on right side. If you understand C# more, better way, then focus on the left one. It will print some numbers. It says print some numbers. I don't have a main method actually here. This is only the recursive method, right? Print numbers is the recursive method, but there is no main method over here. So it will print up to some numbers. Okay. Up to some numbers. If I call this method and by call this method print 30, so it will print up to 30. 1, 2, 3, 4, 5, 6, 7, like 30. Okay. But I want to show you, I have a few minutes, so let me do some demo programs with recursive. But again, if anyone has any question understanding this is a very straightforward thing. Okay, compared to the abstraction and polymorphism, this is very, very straightforward, right? There are not enough object-oriented concept here. All this programming concept. Recursive, right? Okay, so let me call this packet from my last semester, so then I will save some time. Okay, so here what is this method? Is recursive factorial, right? This one I discuss here. I stop here at this point. I put my cursor because this is the baseline. This line is important to understand. Okay, so if I run this method, I'm calling factorial of 5. Okay, so then if I run this, my computer is taking time, it's slow. Actually, I was supposed to restart it, but I did not restart. Okay, so you see the factorial of 5 equal to 120. Okay, so try to understand the use of static. If you use static within class, so this static method is within class, right? I don't need to use call. I don't need to do. Usually, I have discussed that a static method is called by using its class name. But if a static method is defined within a class, then you don't need to use this one. So that I cannot use this one. But if the static method was within another class, then I need to call it by class. So static method is class-wise, is widely known. So for instance, if I mention Barack Obama in the United States, then everybody will guess that I am referring the former U.S. President Barack Obama, Mr. Obama, right? But people in other country, they may have many other people name with same name. So if they want to mention Barack Obama, then they mention as Barack Obama of USA, or the US former President Barack Obama, Mr. Obama, right? So here, if your static class is defined within a class, then it is optional to use the class name to call a recursive method. Here you see that if I should be optional. You see that I can use recursive or I can avoid this one. Even if I can use this class name, or even if I do not use them because optional. If I say if I am within USA, and then if I mention any form the president of USA, then I usually will not say the people or the person of USA or in my country. Okay, so I have 2 more minutes. So let's explain. So if I say n equal to 0, will it work? No, right? If I say n greater or equal to 0, will it work? It's why it is stopping at 1. If I say n greater or equal to 1, 0, then it's stopping at 1, right? Because when you get 4, then it will say 4 is greater than 0. Let me return there, right? So here, even I say n greater, okay, so even I need to say either less or equal to 1. Should it work? If I say it's less or equal to 1, yes, it will work. Even if I say n equal to 1, then it will work, same thing. But if I say n equal to 1, so many people in your test, you will do some this kind of mistake. I'm telling you in advance, and then you will lose some points. Okay, so be careful about this. This must be a logical or relational statement here. So everybody is good so far? Okay, then I will maybe okay, so the last one that I discussed here in give me 2 more minutes, please. Okay, so here you see that if I run this method, what will happen? Anyone has any idea? If I run this method, I'm calling this with 10. I want to run it. Okay, so linked list we will discuss. Okay, so I will discuss this in our next class. We have one more class. For the test? Okay, it's for the test. Okay, upcoming test, it says week 3 to 5. Week 3 to 5, there is no linked list. We will discuss linked list in our next class or next week. Thank you so much.